Welcome back. So in this final section of chapter 6, we're going to talk a little bit about inverse functions and inverse relations. So what an inverse really does is it's mapping every point AB to its opposite, okay? So basically if you notice what it's doing is it's flipping the x values with the y values, okay? That's all that an inverse is doing, okay? Swapping the x's and the y's. So to begin our conversation about inverses, we're just going to start by talking about discrete data points. If I just give you a data table, you should be able to do that flipping for me, right? So if I'm taking this relation S right over here, if I'm taking it and I'm finding its inverse, again, all I'm doing is I'm swapping the x and y values. So that first point, 0, -1, now becomes -1, 0. 2, 0 now becomes 0, 2. 3, 2 now becomes 2, 3. And 4, 3 now becomes 3, 4. Okay, so again, to find an inverse, literally all you're doing is flopping x's and y's, okay? Now there's a couple questions that can go along with that, okay? So the first question is, originally, is that original s a function? Now remember, when we're taking a data table, a function is merely saying that the x doesn't repeat, right? So it's correct that x does not repeat, which means this original one actually was a function. Remember, domain is just listing those x values, and range is listing the y values. Okay? So now let's analyze those same pieces for the inverse. So for the inverse, again, what we're seeing is none of its x values repeat, therefore the inverse is actually a function as well. Okay, it does fit that pattern. The domain is all of its x values. The range is all of its y values. Now there's something I want you to notice is the inherent nature of making an inverse means swapping x's and y's. So if the domain describes x's and the range describes y's, it should also make sense to you. Notice what happened. The domain of the original became the range of the new one. The range of the original became the range or the domain of the new one. They were swapped places, and again, that should make sense because you were swapping the x's and y's. So the domain and range should also switch. There's another neat thing that happens when you look at the graphs of these, okay? So right now, the graph of S is already plotted. So I want to plot the S inverse, okay? So I'm going to plot those 4 values, and hopefully you can kind of notice something. So notice what happens when I draw in that line. They are exact mirror images of each other, okay? In fact, this is a reflection over the line y equals x. Okay, and it makes sense because if I'm flipping the x and y values, it should make sense. So they're just kind of flipping over that line as well because that line is just the same number twice. So now I know this is a lot to take in all at once. So again, let's just kind of take a breather. Let's do another example of this same type. So first off, if I'm asking you to identify an inverse, legitimately all you're doing is reversing the x's and the y's. So instead of 0, -5, we're going to be talking about -5, 0. Instead of 1, -4, we're going to be talking about -4, 1. Instead of 2, -3, we're going to be talking about -3, 2. And then instead of 3, -3, we're going to be talking about -3, 3. Okay? So we're taking all the x's and y's and we're merely flipping them. Now, as we go through here, a very natural question is it a function? Okay, when you're looking at data sets, what you're looking at are the x values. Do the x values repeat? So here, yes, the original was a function, okay? It did not have any repeating x values. However, this time, look at the inverse. If I look at the inverse, it does have a repeating x value. It has an x that's going to multiple y values. So here, what I want you to get out of this is that just because the original is a function doesn't always mean that its inverse is. Sometimes when you take the inverse, it is no longer a function anymore, okay? And that's something really interesting and neat to pick up on, that relationship there, okay? Just because something is originally a function does not mean its inverse has to be. So let's do a really quick recap on what we've done so far. So how do you find an inverse? Okay, how do you find an inverse relation? Well, you just switch x's and y's, right? You saw that in the table there. You're just swapping x and y values when you do it. How are the domain and range of a relation related to the domain and range of its inverse? They swap, right? The domain of the original becomes the range of the inverse. The range of the original becomes the domain of its inverse, right? Those swap along with the x's and y's. And now if a relation is a function, does that mean its inverse is a function? You just saw, no, that is not guaranteed. When you take an inverse, it does not automatically mean the inverse is going to be a function for you. So now we've been talking about discrete data points so far, right? If me giving you a data table. We can do the same thing, however, when we're talking about equations, okay? So we're now going to shift gears and start talking about what happens when we do this with equations. Now, the same rules actually apply here, okay? So I'm going to swap the x's and y's. Okay, now here you may say, but I don't see a y anywhere. Well, you do, because isn't f of x just a fancy y? So to start finding the inverse, the first thing, swap x and y. And now I'm going to resolve this thing. Okay, I'm going to resolve this for y. So that means I have to subtract the 6 over, and I have to divide by 2. And that is going to be my inverse function. I'm sorry, inverse relation. Okay, so with equations, it's the same thing as you've been doing. Swap x and y, but this time you're just swapping the variable, and now resolve for y. Now, I want to show you that the same thing applies to this, as we already talked about as well. So I'm going to graph this first one in green. So y-intercept up at 6, slope of 2, so there's my original line. Now let's graph this. Y-intercept down at -3 and slope of 1/2. And the thing that I want you to notice here is if I draw in that line, y equals x, notice they are perfect mirror images of each other across that line, okay? A perfect image. So now here, the domain and range of lines are actually pretty easy, right? All real numbers, right? I can use any x value, and it's going to give me any y value. It can go left and right, and it can go up and down. Use anything. And same thing here. All real numbers for the blue line as well. So this one you can't really see that flipping happen because both the domain and range were the same thing anyway, right? So now the question, is the blue line a function? Okay, so is the inverse a function? And here I think it's very clear, yes, yes it is. And if you ever need to know, you need to check. Remember, all it takes is the vertical line test, right? If you're thinking graphically, vertical line test says, oh yeah, it doesn't matter where I draw vertical lines, it's only going to touch that blue line once. So it's passing the vertical line test, okay? So don't forget that when you're dealing with things graphically, that's how you can tell. Otherwise, you should just kind of know that any straight line is going to be a function, okay? That should kind of be second nature to you. So let's keep going with this conversation. So this one, we're really going to get a better sense of some of these pieces, all right? So let's look at the function square root of x plus 3, okay? So square root of x plus 3. So basically, remember, that means we're taking the square root function, and remember, the square root function uses, if I plug in 0, I'm getting 0. If I plug in 1, I'm getting 1. If I plug in 4, I'm getting 2, right? So remember, we're taking that function, and we're literally just moving it up 3, right? So instead of 0, 0, I'm moving that up to 0, 3. Instead of 1, 1, I'm moving that up 3. Instead of 4, 2, I'm moving it up 3. Instead of 9, 3, moving it up 3. So here, remember that is my square root function, right? I'm just shifting it up 3, okay? And so the points I just plotted, when I put in 0, I got 3. Then I plugged in 1, and I got 4. Then I jumped up, used 4, and I got 5. Plugged in 9, and I got 6. All right? So those are the points that I just plotted, okay? And that's going to help you in just a second. Because now, let's look at the domain. So the domain are the x values. So in terms of x, I can be anything greater than or equal to 0. And for the range, how high can it go? Well, it's starting at 3 and going up from there. So my range is greater than or equal to 3. All right, now let's find the inverse of this thing, okay? So remember, the inverse is going to be replacing that with y, and now it's swapping x with y, right? So I'm swapping the x and the y, and now I'm going to resolve it for y, okay? So that means I'm going to subtract 3 And I'm going to have to square both sides to get rid of the square root. So that is my inverse function, okay? Now, to find to graph the inverse. Now, if you recall, inverses are literally where you just swap x and y values, right? So if I want to be clever, those 4 points that I plotted to get my graph, if I just reverse them, wouldn't that give me my new graph? So 3, 0, 4, 1, 5, 4, and 6, 9. And I'm getting that, okay? And if you notice, once again, that is an exact mirror image across that line. Now, you may be wondering, that doesn't quite look like x minus 3 squared, does it? Because x minus 3 squared should be a whole parabola. So you may be wondering, why am I only getting this piece of that parabola? Well, because if you think about it, what's happening is the domain of f of x is now derived from the range of the original. So that's why now my domain is starting at 3, because that's where the original range was. My range is starting at 0 because that's where the original domain was starting. Okay, so the reason you're only seeing part of this graph is because now my domain is restricted where it originally wasn't before. Okay, it didn't have that restriction before, but because it's an inverse, it does. Now, is that thing a function? Well, for that, we can picture the vertical line test. And here, a parabola, or even part of a parabola, passes, okay? That is going to pass that vertical line test. So, and then I'll get rid of those so the graph's a little bit nicer if you're still copying that down. All right, another example. So here, again, to help you get a visual of this, let's get some values from this thing. Oh, all right, so if I'm curious what this graph looks like, you should know that it's a parabola. And in fact, you should even really know it's a parabola shifted 1 to the left, right? But let's see, when I plug in 0, 0 plus 1 is 1. 1 squared gives me 1. Okay, what about when I plug in 1? If I plug in 1, 1 plus 1 is 2. 2 squared is going to give me 4. If I plug in negative 1, negative 1 plus 1 is 0. 0 squared is still 0. If I plug in negative 2, negative 2 plus 1 is negative 1, but negative 1 squared is positive 1. Okay, so we're going to start just by getting some values to work with. Okay, so we have this, 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 that. So you should be able to see the formation of our parabola, correct? Just by getting a couple points, you can see where our parabola is. The domain, so the x values our parabola can use. Well, remember, here it's stretching out as far as it can left and right. It's going to keep going forever to the left and to the right. So in terms of domain, I can use all real numbers. What about the y values? What y values am I getting out of it? Well, it's starting here at the vertex and going up. So the only y values I'm getting are y's that are greater than or equal to 0. Okay? And what about the inverse now? So to find the inverse, again, picture this as a fancy y. Now I'm just going to swap them. All right? I'm going to swap the x and the y, and then I'm going to resolve. So I need to square root to get rid of that square, right? Now, here's the tricky thing. Because I just square rooted, I need that plus or minus. So we've emphasized that throughout chapter 4 and 5, part of 6, and now it's coming back again. Whenever you square root, you need the plus minus, and then subtract the 1. All right, so there is our inverse function, or our inverse, I should say. And now, again, recall that if I want you graphing this thing, I can just reverse those points. So 1, -2, 0, -1, 0, 1, and 4. Oh, I'm sorry. 1, 0. What's going on? Let's see here. 1, -2, 0. Oh, that's why I went wrong. 0, -1 puts me right there. 1, 0, and 4, 1. And again, you'll be able to see you're kind of getting this toppled over parabola. And now you can see, just like before, now the original range is now defining your domain. Now the only x values I'm using are greater than or equal to 0, because that's what the original range was. And now the range is that original domain, is all real numbers. Those swapped too. Now the real question though, is this a function? So, is this thing a function? Well, if I draw a vertical line through it, it touches twice. So it actually fails the vertical line test, okay? And another thing that I'm going to point out to help you more easily do this is the reason it's failing the vertical line test is that plus or minus right there. That's a key reason that is failing, because that's giving you 2 branches of that thing, okay? So that plus or minus is a real reason that it's failing the vertical line test, because you're getting 2 branches coming off from that vertex. So now I do want to take a moment, because this is a lot of information, okay? And a lot of this is above what I'm going to have you doing on your own. It's just so you are exposed to the ideas of where some of this is coming from. So the real thing that I'm curious in is, can you determine an inverse, and can you tell me if it's a function or not? All right. So how can you tell if an inverse is a function? Ultimately, the vertical line test. But then if you're only looking at the equation, the real thing is, are you producing that plus or minus that's causing issues? Okay. So again, if some of this earlier stuff was a little bit confusing, this is going to be the main thing. Okay, if you understand this next page, you're going to be absolutely fine. So let's recap what we've been doing. So here, in order to find the inverse, I need to swap the x and y. And now I need to resolve for y to find the inverse. So in this case, that means subtracting the 5 and then cube rooting. Okay, so that is my inverse. Okay, so now the real question is the inverse, is it a function or not? So graphically, a cube root is going to look something like this, right? So graphically, you could think of, well, this is really just a cube root function. So yeah, that is going to be a function, okay? And remember, with the equation, you can tell, because you don't have that plus minus, that's messing things up, giving you multiple branches of that thing. So now, let's look at this next one. Remember, that is just a fancy y, and now we swap them. Oh, that should be a y plus 7. So I have to cube both sides to undo the cube root and then subtract 7. So that is my inverse, okay? And now we want to ask ourselves, is the inverse a function? So again, a cubed looks something like that, right? That's the basic cube function. So that would pass the vertical line test, right? So that is going to pass the vertical line test. Or again, when you're looking at the equations, the equation didn't end up with that plus minus nonsense that's going to cause us issues. And if you look at our last one, so here again, that is just a fancy y. Let's reverse them. All right. So here now resolve for y. So I'm going to multiply the 3 over and add the 8. And again, if you think about what does that graph look like, that is just going to be a straight line shifted up. And so once again, yes, this inverse is going to be a function. Okay, so again, that's really what I want you taking away from this. The discussion of domain and range and all of that is just to show you graphically what's happening in some of these situations. But if you understand this last page, you are in very good shape for me. Okay, so again, a lot of good stuff in this notes. So do make sure to write that summary for me, especially recap this last page. Okay, specifically this last page, what did I do? What do you need? Because that's going to help you be successful as we work towards this test.